Oh, I think we can start. Welcome back, everyone. I lost my train of thought. I think I was just clicking on Windows for a bit there. Well, welcome to Survey of Calculus, folks. This is an interesting class. We're really one overall class, but we're in a combined section of Section 1, typically people in Idaho Falls, and Section 11, typically people in Pocatello or possibly even more remote. Well, before we get started, folks, any questions or comments that you would all like to begin with? Okay, maybe one thing I should say right away or ask about right away is how is it looking for folks coming in through Zoom? Is the audio video coming through clearly? Awesome. Thanks for indicating that, Lauren. Looks like it's doing pretty good for everyone else as well. One thing I did notice in my earlier class before this one was my chat feature is disabled on this. I think I did that last semester for no apparent reason, but I need to turn it on for this class. So I made a note of that. When we come back next class, you are welcome to participate through Zoom. Over voice is definitely ideal. It's more immediate and more clear, but you're also welcome to participate through chat once I get that enabled. It's easy for me to miss those chats, but if that's your only way to participate for any given reason, then it will be available to you. Well, our goal today is really to introduce the class, take a look at how some of the homework systems, quizzes, and those kinds of things are going to work, the Moodle website, and so on. And if we have some time, we'll make some headway into the very first section. But any questions so far? I think I already asked that. Let's keep on going then. So we're now into the syllabus portion. Before running through the syllabus, let's actually go through the Moodle website just to see where everything's at, get ourselves orientated on it. This one document right here is just about exams. Our exams are going to be open calculator, but we only have certain calculators allowed. And it's going to be these two right here. I encourage or recommend the TI-30 X2S. That's a pretty decent one to put in a lot of stuff at once, which works pretty well for this class. So this is one that calculators allowed. And the other one, in case you like it, is the TI-30 XA. A lot of those are used for, say, physics exams, chemistry exams, and so on. So if you're just really good at this calculator because you've had to be, then that would work for this class as well. So those are the calculators allowed. If you don't have one now, well, they're pretty cheap. You could spend, I think this one's like $15 to $20 if I remember right. Aside from that, we also have the Zoom link. And I mentioned before class started, the weather ever goes just completely sideways. We do live in Idaho. Bad things can happen out of the blue, whether it's forecasted or not. Even if you typically come in person, you can come in through Zoom on those really nasty, inclement weather kind of days. This Zoom link is always going to be posted. I use the same one for office hours and my other classes, and it's going to be that same information there. After class is over, the next morning, the class recordings are all going to end up here, and this is really just a playlist on YouTube. You click on that thing, it takes you to something that's empty right now. We haven't had classes. But you could also, if you want to, go through other playlists there to see what's happening with the other classes. Next, we have WebAssign here. This is where our homework is going to be given throughout. And that's where we're going to get our online textbook as well. I want to spend a good amount of class discussing this, but let's skip over it for a moment and come back to it. Let's see here. That takes us to Desmos. This is something I'll use in class from time to time, just as a graphing calculator. Again, because it's a graphing calculator, it's not something you would have access to in a real exam. But if a real exam requires a graph, like what we use right here, it'll be printed on the exam itself. So sometimes I use Desmos in even writing the exam. Aside that, this link right here is a brand new one for this semester. I have a Discord server for really its purposes for student groups more than anything. So if you're working on homework and you just get stuck on a problem, you could email me, see me in office hours, those kinds of things. Or you could go to the homework help Discord server and just post your question there. If you post your question there, it's understood that you're primarily going to be working with your other fellow students in the same class. I'll try to go in there as well as time permits and help out as well. So think of this Discord server as just a way for students, if you would like to work in groups, for study groups and such, that would be a structure where you can make that happen. It's not required. It's not part of the course in any way, just an extra way to get help. Let me see if I can open it. I was struggling at the start of class. If I click on this, I'm not sure if I'm supposed to keep on clicking accept invite, but let's just do it. I'm having a problem with the actual Discord. I'm not sure if this is my problem or if Discord itself is having an issue. I'll try to show it next time we're in class, but the Discord server is there some way, somehow. I have some people registered in it. I'll demonstrate it later on. Any questions so far, folks, about the Moodle website? Okay, after the Discord server, I have a couple articles here that you might want to read about. This one is just to give some motivation of why a calculus class might be interesting, why it might be worthwhile taking. And this one is really just a link on how to study any kind of math class, really. It also contains lots of review topics. So if you click on how to study calculus, it's going to convert to how to study really any math, and there's lots of information here. If you feel like your way of studying is working out pretty well for math classes, I'd say this is worth skimming still. It's always great to pick up new ideas. If you feel like you maybe want to boost up your grade more than the grades you've been getting in the past, you might want to get into a more deep dive on the different elements of studying for a class. The person who wrote this website is, let's see, Paul at Lamar University, and his work is really pretty legendary. Oh, there we go. His work here is really pretty legendary, even though the website is very old, as you can tell. If you click on the bars here, this is where some more of the good stuff comes in. Any review topic that you might need for the course is probably found somewhere right here. You can even get really fast review topics on algebra and trigonometry review. Our course, however, is not going to cover trig. That's part of what makes it Survey of Calculus. We're not using those specific functions. And some of the stuff we do is really just right here as well. You could use this as an alternative way to study for the same class and other topics as well. That's Paul Online's math notes, and it's just from right over here, how to study calculus. So that's the first page of the Moodle website so far. Think of the first page in general as just a way for us to collect a whole bunch of different things that you might use pretty routinely throughout the semester. The very last thing is, well, I'll always be putting my lecture notes in their blank format. The reason for that is, sure, the lecture notes right here are still blank on our current week for 2.2, but after we finish section 2.2, really after today, whatever work we do on 2.2, these notes right here will revise and our solutions will be written in. So think of the Moodle website as kind of like a moving resource. Every time we complete a week, you have all the solutions and information we got through on that week. But if you ever want to go to the blank lecture notes, maybe for the purpose of studying, print it out and things like that, they always go right here. So that's how Moodle is organized. If you keep on scrolling through these, it has all the pertinent dates. I usually put a couple extra lecture notes on there just so I can make sure there's extra material if we just were really fast one day or something like that. Also to give you a heads up, if you want to print these before class meetings, you'll have the availability to do so. If you did decide to print one of these out, think of this as being one big worksheet. You don't have to print it out unless you like to work with paper and pen or pencil. If you're working on these digitally, you could just download them to your laptop when you come to class and just pen these in. That's pretty much how I'll be doing the notes here. And altogether, they're really just one big worksheet, which is pretty helpful for studying. So they'll be blanked out here if you want to ever come back to them. Scrolling through, there's other things like exam dates. I fill out this information in much more detail when we get closer and closer to the exams, along with review problems and those kinds of things, and other things like holidays and so on in our Moodle website. So that's the organization so far. If you ever need help on anything like that, probably one of the best things you could do is maybe click on the syllabus and send me an email right here. I'd say that's a pretty fast way to get help. I'm very responsive on my email, and there's a lot of ways you can interact with me through the email. If you're working on, say, a homework problem, whether it's on WebAssign or otherwise, you could just say, hey, Mike, I'm working on this problem. Take a picture of the work, pretend this is homework on that problem. Take a picture of it and where you got stuck. Send it to me through email. I'll be happy to help work with you on that work there. Aside from email, you can get help directly through office hours on these times and days right here. And these ones right here from 4 to 5 p.m., I'm just sitting in my office with Zoom opened up. So you can drop in at any time. They're completely walk-in, all of my office hours, but they're walk-in for people in person and in Zoom as well. These office hours are a little bit trickier. This is the Math Center or the Student Success Center. And this means I could have anybody coming in, and it's by walk-in appointment. They could be in this class, someone else's class. And although I didn't say Zoom specifically, I'll have my laptop open and you can jump in through Zoom as well. Kind of the way it works in room 220 is if there's a lot of people, we just kind of go in order and address people in person through Zoom. If there's very few people, then we'll just work with those few people. And if you just doing homework, you could just walk into room 220 and just hang out there doing your homework and ask a question if a question arises or not. So think of that as just a general study room as well. So that's getting help. This is the syllabus so far. And running through here, we're not going to do a careful line by line reading, but I'd say probably this is a good portion to take a look at. Pretty much what we're doing in Survey of Calculus is we're doing more work on the functions that you've already seen in a college algebra class. There'll be functions like the linear ones, polynomials, rational functions, think of just a fraction, polynomial above and below. We'll be looking at exponential functions and logarithmic functions. So those will be our big category. But the thing we're doing with them is we're going to see what it means for the function to be a differentiable function. That means it's a nice smooth curve essentially. We'll have more to say about that. We want to understand where the functions are integrable. That's a really weird word, but it means we'll be able to get the area under its curve. And other kinds of concepts. So we're extending our work on functions just to look at additional concepts about those same kind of functions. Any questions about that so far? Okay. Our homework is going to be primarily online, but it's really split into two kind of regions. The online homework here is through WebAssign, and registering could be done through this link right, or this course code right here. But again, I want to spend a good amount of time today giving a little bit more detail about that. Aside from homework, we'll also have quizzes, and quizzes are going to be assigned on a weekly basis. I'll typically assign these on Wednesdays to be due the following Monday. At the end of the semester, we're going to drop the lowest two. And quizzes are just an opportunity for you to do a pretty fast problem. It's not meant to conflict with the online homework. So the online homework is where a lot of your work will be done. I think of a quiz as you're pretty much just writing down a short report on a really fast mathematical problem. You'll send it in to me and I'll see about where you're at on those topics. Yeah.
Go over those after we make the quizzes.
Yeah, absolutely. Yeah, after the quizzes are done and handed back, you're absolutely welcome to ask any questions you like on those. Other questions so far? Okay. Aside from the homework, the quizzes, there's also the exams. And there's a lot of stuff here on exams, but we'll come back to this when we're getting closer and closer to one. Good things to say right away is we'll have 3 75-minute exams, and we'll have 1 comprehensive 2-hour final exam. These exams are not necessarily in person because there's lots of ways to participate in this class. You might take the exam in this classroom physically, but if you're coming in, say, from the Pocatello campus, it'll be more on a Pocatello campus testing center. So those kinds of things. Does that make sense to folks about the exams themselves? Okay. Let's go down through here.
So really quick, I got a quick question on exams.
Sure.
So if like all of us in Idaho Falls on the Zoom class, do you want us to come in there in person to take the exams, or is there like a online proctoring web?
I think it would be ideal for the folks on the Idaho Falls campus just to come to the classroom to take the exam. But if that doesn't work for one reason or another, you can also take it, say, on the Idaho Falls Testing Center as well. So really, there's like 3 different modes of taking the exam. You could take it physically in this classroom, room 215, or you could take it in the Idaho Falls Testing Center, or a third way, you could take it in the Pocatello Testing Center. Does that make sense about that?
Yeah, that makes sense. Just wasn't sure where we were supposed to go, so.
Gotcha. Other questions at the moment? Okay. Well, that's our breakdown of the course so far, just the elements for grading. The way the course is going to be graded is in this format right here. Things I think are kind of unusual about the format is the final exam is a little bit low compared to what a typical class might be. Usually a math class is like 30, 35% or something like that. I dropped it down to 25 and boosted the homework. I feel like for this class, the homework is so fundamental and pivotal that really the best way to learn calculus, whether it's a survey class or not, is you really just have to do a lot of problems. There are so many different kinds of problems that without really hitting the homework hard and giving it its due weight, it's not as easy to be successful in this class. So the more homework you do, the better off you'll be. So I try to support that by bumping homework to 20%. This is the web assigned homework. Quizzes are going to be at 10%, and each exam will be 15% each, leaving just 25% for the final, but I think that's a good breakdown for this specific class. So that's how the grades will be assigned at the end of the semester.
Will we do any kind of review, like the exams or anything, if it's kind of like?
I'd say it's going to be, sorry, I kind of misunderstood your question. Yeah, for the exams themselves, when we get closer to this date, I do put in review problems, absolutely. So there'll be reviews problem sets for every one of those exams. Other questions so far? Okay, well, that's kind of the major elements of the syllabus. We have our day-by-day schedule right here. We have a couple good holidays, Martin Luther King Jr., President's Day, and of course, spring break. And the other things are firm as dates are pretty much exams and the no class days. So we'll have exam 1, February 5th, 11th of March, and so on. Our final exam on finals week, I believe, is going to be on Monday. Let's see if we've got that in. It'll be Monday from 8 to 10 p.m. Now, that's one thing that's a little bit rough about this class is because we're a night class, the registrar throws us a really nasty final exam time. We get through it, and I do typically curve the final exam because I feel like none of us are at our best doing a 2-hour exam all the way up to 10 p.m. So I try not to make the final exam a really big deal. And that is one exam that I do typically curve at the end of the semester. So although that's a pretty rough deal, think of the final exam as a formality. We'll definitely get through it. It'll be warmer weather too. It'll be more palatable, I think. So that's our day-by-day schedule. If we go through here are the university resources. Yeah, go ahead.
So for that final exam, if we're in Pocatello, do we still have to go in at that 8 to 10 hour time, or do we do it at the testing center?
It'd be at the testing center, yes.
At whatever time, or?
Yeah, it would have to be for the testing center. It could be at any time, but it would have to be on the 29th.
Okay, thank you.
Yep, you bet. I'm glad you mentioned that. The same applies for people in Idaho Falls. If this time does not work great, I will be here at 8 to 10 p.m. no matter what for anyone who shows up in person. But send me an email and I can arrange for your final exam to be in the Idaho Falls Testing Center. And that way you could avoid a potentially really nasty exam time. And like you mentioned, same offer extended to the Pocatello students. Other questions about that so far? Okay. Well, the last thing left up on the syllabus is just the university resources. There's a lot of reading here. And for some of these things, if you read it once, you probably know what it's all about. But if something like, say, Title IX just seems weird, that's definitely worth reading very carefully. These are all pretty important statements for any class you're taking on the university, not just a math class. Some of them are directly for the mathematics department. So this one right here is about grievances. You can always contact Dr. Rawl. Anything that just doesn't seem right, he's a really good contact person. He's the chair of our department in the mathematics and statistics. And there's lots of other things on here. So again, if you haven't read through here, it's good to at least skim. And if something looks like new that you've never read before, a deep dive, a careful reading might be a good idea. Well, that's our syllabus so far, folks. Any questions or comments whatsoever? Okay, well, let's go back to our Moodle webpage. Like we mentioned, pretty much everything we do in our class is going to end up here somehow, some way. All of our recorded lectures are going to end up here. They'll be posted on the next day after the class meeting is over. And you'll always know what we're doing. Just go to this week on the Moodle webpage. You'll see the documents that we're about to take on. If we don't finish section 2.2 today, we'll just have it left here for when we come back on Wednesday. And if for some reason we don't finish it on Wednesday, it'll just move down to the next week. Wherever we finish it is where it's going to stay, and that's where we'll post the solutions as well. So I guess we're just about ready to get started. Any last questions or comments or anything whatsoever, folks, before we begin? Okay, let's convert then to the lecture notes. I usually don't click things off of here on the Moodle website since these are really just PDFs. Oh, I was. Thanks for mentioning that. That'd be a terrible thing to skip on the very first day as well. Thanks for saving that. So as Carson mentioned, we want to take a look at, well, how do you do the homework in this class in the first place? That's probably more important than hitting the lecture notes right away. So our course is going to be administered through WebAssign. If you click this, it'll take you directly to it. If you see this page right here and you're registering for the first time, you'll probably just click on this, enter your class key. If you've used WebAssign before, it might be simpler for you to just sign in and then you enter your class key later on. That might be a simpler process, less logins to remember, that kind of thing. Let's move some of these over. If you click on enter class key right away over here, then, well, they want your course key. They change it from class key to course key, but it's still the same thing. And you can find that right here, the course key. What I would do is just use your mouse to copy this and directly paste it in. That's probably the easiest way to get through. Click on enroll right at this button. And this should be the page that you see. It should say Michael Jacobson, Math 160, Section 1 or Section 11. That tells you you're in the right place. Click on continue next. And this is where, well, it's going to be a little bit harder to show the very next steps. But if you have an account, this would be a good time to sign in. If you've never used WebAssign before, you definitely want to click on this next, create an account. And then answer the pertinent questions there, and you're on your way to WebAssign. I saw in the class about 6 people have already registered, so good on you to those folks who are already ahead of the game there. If you haven't registered for WebAssign, you're okay. I'd say if you come back on Wednesday's class registered, you're definitely still caught up for the class. You're in a good spot. Now, that's kind of hard to show since I don't have different emails and logins to show signing up as, say, a pretend student to demonstrate. But I did do that once. It's right here, the setup instructions. So if you need a little bit more clarity on those steps, you can open up this PDF, and this is the full process. Let's take a look at it ourselves. So go to the website, click on class key, throw that inside there. That's about where we ended up. It'll show you this to click continue on. After that, it's going to say review purchase options. In other words, they want their money at some point. It costs $109 for the online textbook and the homework system altogether. And you can also go to temporary access right down below here. This gives us 2 access completely free. So if right at the start of the semester, you don't have $109 laying around, I don't either, that's okay. You can still work for 2 weeks and there's no loss to any of your grade or anything like that. At the end of the 2 weeks, though, we're minus for access, but you just continue on the same account. No work is lost. Any questions about that so far, folks? Okay.
I got a quick one.
Sure.
So it says that there's a one-term access and a multi-term access. That the multi-term access is $72. So do you know what the difference between those two is?
I do not. I'm going to have to take a note of that. Thanks so much for spotting it.
Yeah.
So multi-term for 72. I have a little bit of homework today. Multi-term access is $72. That sounds like the better deal.
Yeah, that's what I was thinking.
More time. So I don't see any reason why you'd want to spend $109. I'm glad you saw that. But what I'm going to do is I'm going to take a look at this. I'll play around with the system probably around sometime tomorrow, and I'll come back with an answer on this for folks. So maybe don't buy anything yet. I recommend everyone do temporary access at the moment while we figure out this weird price discrepancy. 72 sounds like a good deal. I just want to make sure you don't purchase that and miss out on something. Again, thanks for mentioning that, Walker. I'll take a really close look at that after class. Let me put this post-it in a place I'll see it. But other questions at the moment? Okay. Well, again, once you're registered for WebAssign, you're pretty much ready to begin the course. But let's go to WebAssign ourselves just to take a look at what does it actually look like. So let me attempt to log in myself. Oh, I have a button right there. Look at that. Again, you can click on just the WebAssign right here, or just go to webassign.com. I do have an account. Let me just hope I know the password still. Google tells me multiple times this password has been leaked, but hasn't caused trouble just yet. I need to change that thing. So here's what WebAssign looks like as soon as I click on this. So once you've registered for WebAssign, and once you clicked on this specific course, you are taken right to this page. And this is pretty much where everything pretty much happens. Right here on My Assignments, this is the homework itself. And it's just organized by when the due dates are. So the first one is due on January 17th for section 2.2. But here's how the due dates really work. Back here on the Moodle website, we're on section 2.2. The moment we finish that section, we'll have a 1-week turnaround, and the due date will be 1 week after this is completed. So if we complete it today, it would be due on the 15th. I have a due date on the 17th, so I'm thinking we'll probably complete it on Wednesday of next class. If we need to take more time, then these due dates will revise. So once a section is completed, it's a 1 week turnaround on the due date. But another thing that's kind of interesting about these due dates is, more than anything, they're just about pacing. If you're completing all your assignments by the due dates, you're in a really good shape for completing the exam with a high score. And so think of these as stuff we should get done before that due date, just to be keeping up with the class. If life happens, if work gets busy, other classes get busy, and something does go past due, we'll request an extension. You don't lose any points for the course as long as you complete those problems. So that's how the homework is going to work. So once you're registered at WebAssign, say you logged in, you clicked on the course survey of calculus, you're taken to this homepage, and just click on the next assignment to do. It's 2.2. WebAssign is not the most beautiful looking system, but it's at least kind of simple. It's a definite set of questions. This homework set has 7 problems. I selected all of these 7 problems pretty much spaced exactly by these problems that we're going to be doing here. So when you're doing your WebAssign problems, if you have what we did pulled up as well, that could be a good way to study as you start to work through the problem simultaneously, getting extra support. So here's our first problem. It says find the limit if it does not exist. Enter DNE. And that's kind of a weird problem. We've never described it. So if you feel like you run into a problem that just seems crazy out of the blue, there's a lot of things you can do here. You can click on read it. If you do that, it's going to take you to the exact portion of your textbook where this problem is coming out of. Well, thereabouts. You click away those little things. So it's taking us to section 2.2, limits of function at infinity. And this is your textbook right here at this stage. You click on the right arrow. If you had a real textbook, these would be the pages of that real textbook. So it's a nice duplicate. That's going to tell us about what we're really doing on these problems to help us solve this one right here. So that's one way to get help. Another thing you can do is, oh, sorry, go ahead.
Will the quizzes have similar problems to the homework?
It will, yes, absolutely. Pretty much what I do with the quiz is I take all of these 7 problems. I try to distill it down to one question with maybe 2 parts, but usually one overall question. That's that way. The purpose of that quiz is so I can see what it looks like writing out your work on a step-by-step basis, and it makes it more similar to an actual real exam question at that point. So think of the homework as you're really practicing getting to that stage. The quiz is a little bit more of a finality kind of thing. It's like a slightly higher, more, what's the word I'm looking for here? Slightly higher level of learning after the homework and the quiz itself. Then after the quiz will be the exam, where all these kind of problems are meant to support those questions. Other questions so far? Okay, so here's the homework. You can click this to take a look at the textbook. And you're also always welcome to click on this button right here. Ask your teacher. If you click on this, here's what you might say. It could be pretty much anything. The more you give me, the more I can help out. If you indicate me the portion of the problem that seems kind of vague or foggy, that can help me on wording out a response. But you're also welcome to say, I mean, if you're not sure what to do on this one, you could say, hey, Mike, I'm stumped. And that's fine as well. Click on send. And then a couple things happen. I get a notification over here. Eventually, once it reloads. And I also get a notification on my Google email so that I know that there's questions I need to take a look at. I'll go here. Go to that question. And when I click on this, the kind of nice thing about this system is it shows me the exact question you were looking at, all of your prior responses, things along those lines, and then I can give you some kind of reply to help out. So that's how the homework works. And one thing I say every time I use WebAssign, and always is worth repeating, this button right here is never, ever a bother. If you clicked on this a lot of times for a single assignment, that's okay. I just try to get back to your messages in the order I receive them. I'll always get back to your question. The moment I respond to your question, a couple things will happen for you. You'll see something right here that there's been a response to your, well, this is not quite what it looks like. You'll see on your account somewhere over here that I've responded to your question, and it should also mention it in your Google email that I've responded as well. So that way you know that there's been a response. And the thing I was trying to say is you can use this button a lot. You'll never be overdoing it. I'm a pretty fast typist. I'm very happy to help out. So this homework is really just strictly practice. You need a lot of help getting through a single problem. I think that's completely fine always. So we're talking about a lot of stuff on this for WebAssign. Kind of my goal is after you register for WebAssign, try it out on Wednesday. We'll come back on Monday. I'll point out a couple more things here just as a refresher. So it won't feel like we just jammed a whole bunch of things in a very small amount of time. But while we're here, any other questions or comments, folks, about WebAssign? Okay, maybe one last thing. Once you're done with, or once you're working on the homework, a couple things that are interesting here are, if you put in a number, say like 5, I doubt the answer here is 5. If you click on submit answer, well, that one was wrong as we kind of predicted. Oh, what problem was I on? Very top, thank you, on problem 2. So we got it wrong. There's a little X right there. We got it right. They would just put a blue check or green check mark. And all of that is saved pretty much at that moment that you get feedback from the system. They put this button down here. They used to put down a button that said submit assignment. They might have taken that out at this point. But every time you submit on something, it's automatically saved. You don't have to do anything further. On this problem here, I missed the question pretty much intentionally. And you can keep on missing the question. They don't give a lot of help, though. After you miss the question multiple times, there's no real feedback or guidance. This system is kind of primitive compared to other things. Yeah.
I've had other classes in the past where if you're like 0.1 below or 0.1 above, it would still count as correct. Does this one do that? Or?
It does do some of that as well. Yeah. It's less as a big of a bother in this class because the answers we're getting, they're not like numerical rounded values. They're usually dead on answers like this for a lot of the different problems. So it becomes less of a bother, but it still is an issue. And because that's an issue, I put about 100 attempts on every one of these problems, which is kind of outrageous, but I want people to really give it a solid chance. And if it's a rounding issue that they're giving you trouble over, that should never allow you to lose the whole question. And again, if it's just not coming out right, they don't give us a lot of advice. They point you somewhere in the book, but you're always welcome to click on this, ask your teacher, and I'll be very happy to help out. If it was something like a rounding error, if I can tell you really have the right answer, but it should be 5.92 instead of 5.91, I'll just tell you that looks like a rounding error, should have came out to this. So WebAssign is a bother with rounding, but use this button as much as you like. We'll definitely get through it. Other questions at the moment? Okay, well, maybe one last thing to leave you with. After you register for WebAssign, one good thing you need to know about is where is my book at this point? And so go to home. Oh, there's usually a thing that pops out here. We go to resources. I believe under resources is where your textbook is. I'll take another look at this to be sure. Click on, say, chapter 2. And where are we? We're in section 2.2. Oh geez. And well, these are lecture videos. So book resources. Oh dear. All of these are book resources. I got to the book in a weird way. I clicked on a problem in section 2.2. I clicked on read it and I pulled this up. This is where your book is. There's an easy way to get to this, but my student view is not showing the full website that you typically see. So this is your book right here. And it just gives out the topics on a section by section basis. We're currently in section 2.2. So probably a best practice for this course overall is you'll always know about where we're going to cover, what section we're about to go into. I always give this information here. If it says read section 2.2, it pretty much just means the whole section is really good reading worthy for us. Occasionally I'll say you can skip this example or this section to let you know this part of the book we're not covering for that lecture. But aside from that, it'd be a good idea for best practice to open up section 2.2. And any kind of reading you can do here before we start class is always very helpful. Even if it's really just skimming through, taking a look at some earlier examples, maybe reading some definitions. Anything you do before class is a big help in absorbing what we're about to do in class. It just kind of primes your brain to give you some traction on latching on ideas you've seen once, giving it more detail in the lecture notes. Well, we've talked for, wow, 36 minutes. Any questions or comments so far, folks? Okay, when you go and work with WebAssign and get registered, if you have anything, issues that come up, please don't hesitate to email or come in office hours, things like that. Our class is kind of nice because at 8:15, this is my last class. So I'm also able to help as a kind of impromptu office hours after class every day as well. I'll be available right when class ends. But aside from that, looks like we're down here in section 2.2, we're about ready to begin. Thanks again to Carson for reminding me we want to look at WebAssign before that. But any other questions or comments so far, folks? Okay, let me organize my tabs here a little bit better. Let's go to section 2.2. Now, these are the PDFs. If you want a Word document, go here to the blank lecture notes, and it's here as a Word form. But word of warning, from these Word documents, I use a lot of equation editors, so if things aren't showing up nicely on your machine, you might want to use the PDF. If you're printing something out, the PDF is definitely what you want to use. There's weird things that can happen printing out a Word file with an equation editor. So in section 2.2, this one's just the PDF. But what I do is I go to my thumb drive and grab it from right here. Again, everything on my thumb drive is duplicated on the Moodle website as well. So there's nothing you're missing out on. And here's where we'll begin. Whatever we get to, however far we get to on these notes, we'll save it and upload it back to the Moodle website as a PDF, so you'll know when you come back on Wednesday where we ended on how far we got. But this is the first start of calculus. We need to know what a limit of a function is, and that's a weird statement already, so let's begin right here. It says to begin, let f be a function defined on some interval from a to infinity. Then, here's a really crazy statement that we're going to break down very carefully. Looking at this portion right here reads, the limit as x tends towards infinity. So we're dealing with the limit. This portion right here tells us we're taking the limit of a function or a curve in the plane, y equals f of x. Here we're writing it out this way to indicate sometimes we'll be using function notation. Other times we'll mix it and write just a function y equals x squared plus 1, for example. So we're taking the limit as x's get larger and larger as they head towards infinity of the function f of x, and somehow, some way, it's equal to L. So what we did here is we read out what the structure is. Calculus is sometimes pretty heavy in the notation, but the notation, all of it is extremely important. any small change here can have a completely different meaning altogether. But it says, if this equation is true, equals L is really true, the values of f of x can be made as close to L as you like by taking x larger and larger and larger. X getting larger and larger is kind of conveyed right here. X is heading towards infinity, so x has to get large. I'll probably have to undo that. We don't want the notation to get too busy here. So this is the mathematical statement, but what it leaves off is the actual picture. When you're learning a new structure like this or a new subject like calculus, what your brain desperately needs is lots and lots of pictures. So that the meaning here in words, we can see it as an actual picture altogether. So let's now draw out the definition. It says it needs to be defined on some interval from a to infinity. Now this a could also be negative infinity to say it's all real number lines. The thing that's important is if x is heading towards infinity, there has to be infinity right here. So let's draw it down first. Let's go right up here and go 1, 2, 3, 4. We have a height at -4 on our function. And what I want to put down is a horizontal asymptote. So as a dashed line, here's our horizontal asymptote that goes through -4 on the y-axis. So here's y equals -4. Next, let's put on this plot the actual function itself. We're applying the function as blue for f of x. And there's a lot of different functions that could work here. If we decide to start it right at a, it might begin here. And because it's beginning right there, we'll use a solid dot to say, this is a point on the graph, and this is now going to be the very first point on its graph. We're only going to put in values to the right, going off to positive infinity. So here's what the function is doing. It's moving off in this way and approaching the horizontal asymptote just like that. This is the function y equals f of x. So everything you see right here on the graph, all of it, I'll temporarily highlight this just to convey the thought here. Everything right here, this is just temporary highlighting, is conveyed right there in that one little compact statement involving the limit. What you see in the graph is what's right here. Now let's explain very carefully. So looking at this curve in the blue, it moves to the right and it settles down at some height, around a height of -4. That means we can write down that the limit, the values of x are going off to the right. So we'll say as x goes to infinity, but the moment you write that, you have to say the limit of what? It's the limit of a function, so we throw the function inside. The limit of f of x. So this is an operator, and the input to that operator is an entire function. And then this segment right here says what you're doing to the function. You're sending x off to infinity. Now follow the blue line. If x goes off to infinity, the value it's getting closer and closer to, its height, is a height of -4. It doesn't actually have to ever reach -4. It just has to get as close to it as you would like. Say -3.9, -3.99, -3.999, and so on. Your function can never even hit 4, but this, if it can be made as close as you want, we'll say is equal to -4. So that's our definition right here as a particular example. Now, the thing that's kind of interesting that is sometimes a really big help for these problems is if this limit had an answer, say -4, that happens if and only if your function had a horizontal asymptote as you moved to the right. So these are not accidents here and here. And in fact, that statement is conveyed down below here about horizontal asymptotes when we get to that portion of the notes. But that's our first look at limits. Again, there's a lot going on here. But the thing that's terrible about this, but also important at the same time, is every bit's important. You have to specify let me try again. You have to specify the direction. So this is something you'd want to look at first. What's happening to x? Is it moving to the right? That means you have a positive infinity. It's moving to the left. That means you have a negative infinity, like on this one down below. The next thing that's important is you have to give it a function. You have to say the limit of what. And then you have to provide an output. That doesn't combine well. Our outputs happen to be -4, but sometimes the output, it might be, does not exist. Sometimes the limit doesn't give us a right value at all, or a finite value at all, I should say. Well, this is our first look at calculus. Calculus is first defined is a subject about continuity, differentiability, and integrability. All of those interesting comments or concepts are all through a limit. So every element of calculus that we would want to study is somehow, some way conveyed through these kinds of limit expressions. Well, let's turn it around and take a look at this other limit. First, any questions, folks, on our illustrations here? Okay, let's put just a quick border. No, actually, these go together. We can leave the border off of that one. Let's turn it all around again and look at that statement. So this time we have a function f of x right here. We have another limit over here that can be any finite number. But the new thing is, now this time x is going towards negative infinity. So there's a switch on the directionality. So we had to take x to be sufficiently large here if x is going to positive infinity. If x is going to negative infinity, we want it sufficiently large negative. So -1 million, -10 million, and so on are the values x should be tending towards. So then the function f has to be made arbitrarily close. In other words, it's going to get closer and closer to L as x gets larger and larger negative, meaning it's just moving further and further to the left on your graph. The function should come down or up to a height of whatever that number is. Well, let's put down a new illustration, and it'll look about like this. For these limits to exist, because of the infinity here and the infinity here of different flavors, but the fact that there is infinity, really the first thing we're plotting is a horizontal asymptote. That's when these limits exist in the first place. Let's put one maybe right here at height 2. So right around at height 2, if we let our function go far and far to the left, sufficiently large negative, we want to hit around this height. So our curve could do something like this. This time we could let it go up and to the right forever. It doesn't necessarily have to start at a specific a value here. So I'm letting a be really a positive infinity in spirit. But now as we go to the left, let's let it do some wild stuff. But eventually I want to get closer and closer to this height, a height of -4. So this is our new graph for y equals f of x. The graph has to pass the vertical line test to make it a true graph of a function. But aside from that, if we're taking a look at example for this limit, let's read it out from the graph. Reading this graph, we can say the limit. Now, the direction we're most interested in is this way. We're going to the left, so we'll write that out by saying x towards -infinity. Reading the x with the arrow, you could say as x tends towards -infinity, or you could say as x heads in the direction of to the left, -infinity, or as x gets larger and larger negative without bound. There's lots of ways to write that, sorry. The moment you write down the limit, you have to tell this structure what you're taking the limit of. So f of x goes inside. Now, after doing that, we pay particular attention to the -infinity this time. That means we're following the curve in this way. As you trace out the curve, only going to the left now, lots of stuff happens, but eventually it dips down and it settles around at this height. Putting an arrow here says nothing interesting happens beyond this point. It's just going to have that same pattern. Same on this direction. It's just going to go up and to the right forever. As it heads here, it's heading towards a height of +2. So we'll put a +2 here to finish off this limit statement. Well, we did it, folks. That's looking at our first two limits for the whole course. Any questions at all looking at these at the moment? Okay, so what we're trying to do at the moment is take stuff that we can convey in a graph, writing down that as limiting statements. At this point in the course, it's not completely clear how limits give us more intuition about functions, but before we're done with chapter 2, we will define the derivative, and we will use these limits in its definition. So chapter 2 resolves why we're doing a pretty strange topic to start out. Well, after we have limits, next thing we'd like to do is calculate some more of them. And because this is a first class, some of these problems are really just graphically. Here it says the line y = L is called a horizontal asymptote of the curve y = f of x if either one of these limits exist. So if you're going towards positive infinity and it settles down to a value, then you had a horizontal asymptote, like we mentioned here. Or on this one, it's going towards negative infinity, going off to the left. But if it does settle down to some finite value, then we'll just say it = L due to that horizontal asymptote. But notice if you're going to the right on this curve, there is no horizontal asymptote. I drew it so it's going up and to the right in that direction now forever. Let's say something about this right here. Because we're going to the right, we would write lim x tends towards positive infinity. We're shooting it up in that direction. Let me just put an arrow here to say, for this region of the graph circled, this is the limit statement that's going along with it. We're taking the limit as x tends to infinity of f of x. And there is no finite number this approaches. The moment you put a number down, well, move a little bit more to the right, and the function has gone up and above that number. It just keeps getting higher and higher and higher. So this is what we write. Equals infinity. There's no finite value that we put there, but if we want to convey what's happening on the graph, this is the symbol that says it. The function values don't settle down. They just keep getting higher and higher and higher as x moves further and further to the right. So essentially, in a weird way, everything that's conveyed right here can be paraphrased as just one statement like that, giving us the end behavior of the function going off to the right. So those are our two limits here towards positive infinity and negative infinity. There was only one horizontal asymptote at that height, and so only one of the limits existed. We only could put a 2 here. Well, with that information, let's try it out next. First, any questions at all, folks, with any of these illustrations? Okay, so our next goal here, with those definitions under our belt, this problem right here, it's still not a problem that's in the homework, but it's going to help us visualize these kind of problems, and we will see some of these graph problems in the homework in the upcoming sections. It says the graph of a function f is provided below. So the function is this squiggle line, and this line. It's in 3 different pieces. This function has discontinuities all over the place on it. That's all over one function. It never fails a vertical line test, so it's also truly is a function. And just for the sake of practice, let's do 2 limits along with this. First one, we're going to hand off towards positive infinity. I'll leave this one up to the class, whether you're in Zoom or in person. Anyone see what this one should settle down as, if it settles down at all? So I'm saying 1. How do folks feel about that? Do we agree, disagree? Awesome. So I agree, yeah, this one should be a height of 1. I scrolled more than I wanted to, because if you look at this part, where it says x tends towards positive infinity, I need to stop changing the size of this highlighter. Let me fix that. If you look at this part where it says x tends towards positive infinity, that means this is the portion of the curve that you care about when it's moving towards the right. But if it's moving towards the right, that's indicating a horizontal asymptote. Like you said, it looks like it's approaching the height of 1, coming in through here. So that resolves this limit here. And it's the same game on this one. If you're heading towards negative infinity, let me see if I can get a different highlighter. So on this one, we're heading off towards, that highlighter does not really show up. Let me try one more time. There we go. This time we're heading towards negative infinity. That's just a fancy way to say X is moving towards the left. So we're in the complete wrong spot here. We move over this direction, follow the curve. And if we're heading to the left, well, it does some weird things, but our function can cross a horizontal asymptote. And it looks like at height 2, by what they plotted for us, that is a horizontal asymptote. We'll always assume enough of the function is plotted so we can ourselves determine all of the end term behavior. If something wild happened here, I would have to have plotted it. So here we'll just say equals 2. Again, we have to read where X is tending towards in the limit statement. And this is the part of the graph that got us the answer here. We did, folks. This one was pretty fast. We have a limit of 1 on the right, a limit of 2 on the left. Now we want the equations of the horizontal asymptotes, but really that's not so bad. In some sense, knowing a horizontal asymptote is completing the limit. So if you have the right values here, you just go down and say y equals 1 from that one. Come over here, y equals 2 from this one. Feels very redundant because we also put them on the graph just to illustrate them. The horizontal asymptotes are giving those limits. But the only reason they're giving us the right limits as horizontal asymptotes is because of that part right there. X doesn't have to tend towards positive infinity. It can head towards all sorts of different directions. We could head towards 2, for an example. And that one's a wild limit. We'll save that for when we're in section 2.3 coming up. Well, we did it, folks. That's our first example for the whole course. Any questions or comments about it? How about folks in Zoom? Is this looking all right to folks so far? Awesome. Thanks for indicating that, Lauren. And for folks in Zoom, again, I have a weird misconfiguration on Zoom on day 1. That's unfortunate. Voice works for feedback, but I still want to give folks the opportunity to ask questions through text. So I'll get that fixed on Wednesday's class. You can give me feedback through text as well if you're more comfortable, or some people are just in a noisy environment, and that's the best way to participate as well, and that's always okay. Well, let's take a look. We've got a good 18 minutes. And this next question is, well, it doesn't look fun, but it's not as bad as it looks when you take a look at this. These are the limit laws, and what they're telling you is, these are the properties you can take for granted when you go to calculate limits. Now, example 2, parts A, B, and down, these are now very similar to the ones you're going to see in the actual homework problems. So we want to take some careful work on these. Maybe for us, let's do example 2, part A, and make that our last question for the night. Does that sound all right to folks? Okay, we'll end class a little bit early, so if you have questions after class, that'll be a good opportunity to ask them. Also, I'll give you an opportunity to register for WebAssign before we get too far into these notes here. I think I spit on my monitor. Let me fix that. So again, the limit laws look really imposing. You're joining a calculus class for the first time. And if you looked at the syllabus really carefully, it feels more disheartening because the exams themselves are closed notes. But I do provide actual notes itself on the real exam. If we're taking a real exam, I'd probably provide limit laws like these on the actual document of the exam. So although it's closed notes, stuff like this is provided. I'll give you a good indication as well of what's on exam, what's not on exam, well ahead of the actual exam date. So here's our very first one. We're taking the limit as x tends towards infinity of 1 over the square root of x. Our goal here is not to plot it this time. We want to know its exact limit through the limit laws. And it turns out the limit law that helps us the most is this one right here. Let's illustrate that one just to see what's going on with it. So to get a feel for limit law number 8 that we're going to take a look at next, let's just give it a function that looks like this, 1 over x to a power. So here's 1 over x to a power of, say, -2. That's a weird power. This corrects to x squared itself. And here's what the function would look like. If x is tending towards infinity on this function, the whole thing would go up to positive infinity. Much like what we did, oh, sorry for the random scrolling. Much like what we did right up here. It's not settling down, there's no horizontal asymptote, there's no limit for this one. But the limit law said the limit of 1 over x to a power is 0. We're not seeing that here, but here's what goes wrong. The power that you put in right here needs to be greater than 0. We put in a negative power, so the whole thing is going wrong. We put in, say, a power +2. Here's what the graph of the function looks like. And definitely, if you go towards positive infinity, the whole thing is heading towards, yeah, it looks like 0. Let's even blow this up to get a good feel for that. Heading towards positive infinity means the curve is moving to the right. In the purpose of the limit, you're looking at the second coordinate, 0.541. We're heading towards positive infinity, you move your mouse to the right, and observe the values are definitely getting smaller. If you want it to get, say, below 0.0009, let's go clear over here. Let's see, clear over here. We're below 0.00, oh, that's going to be a while. Well, the further you move to the right, the smaller it's going to go. So pick any small positive number. We can go below it by just moving x even farther to the right. So that's what this is saying, 1 over x to the power. That makes part A right here kind of a confusing problem. The limit as x goes to infinity of 1 over root x does not exhibit the actual power, so we need an extra concept on this. It's not so bad, but in calculus, we do loads of algebra, and a lot of the algebra we do is exponent laws. Here's one important one for us. If you see a root x, anyone recall what the true exponent should be for a square root? Let's put down a couple versions. This one turns out to be easier in a weird way. If it was a cube root of x and you want an exponent on it, you go like this. Take the index, which is 3, since we're taking a cube root, and it converts to 1/3. So we have a fractional power, really. So any power that's a fraction can be written as a radical notation like this. So the square root of x is special. We don't typically put a 2 here to indicate the square root, but it converts to 1 over x to the power 1/2. So over here, going back to our limit statement, we can say that this is the limit as x goes to infinity. When it says write correct limit notation, that means we have to write the limit structure once more on each of these steps. So we're taking the limit of the function, which is 1 over, instead of root x, we'll call it x to the power 1/2. But now that we put in the actual power, we can look at the assumption required on limit law number 8. It said the power has to be positive. And the power had to be right here exactly when it's positive. That's what we're exhibiting here. And if you can show that those things are correct in the right order, then we've got the limit, folks. The whole thing is equal to 0 from limit law number 8. So in my opinion, limit law number 8 is a really good one. It's kind of a power horse for this class because it's fast to use and it's easy to observe when it's going to give you a right value or an incorrect value. It gets confusing with roots, but then use this information here on the right to convert it into an actual exponent. So my claim is, through limit law number 8, as x gets larger and larger, this one will turn into a 0. We're trying to get the exact value, so we're doing this on paper with limit laws. If you're not sure if that feels right, you can always do this as well. Go back to the plot, put in 1 over square root. Try again, square root x. This is what our curve looks like. And yeah, if you move over to the right, based on the work we've done, it does look like this is heading towards 0. We just have to move pretty far to the right to see it getting really, really small. So that tells us this is the right behavior as per this graph here. Well, any questions, folks, on our very first algebraic limit? Okay, well, the graphical intuition we get here, like on the problems above, versus the purely algebraic way, just doing the analysis, they're both equally important, I'd say. When you're doing these in homework for section 2.1, we're really going to be writing them out like these on our quizzes and upcoming exams, but it's still a good idea when you're just learning at a subject, use additional resources just to help you out. If you can graph the function to get a feel if you're on the right track or not on the right track, that's probably a good idea. Desmos is a fast way to do it. We won't have graphing calculators on an exam, so for these kind of problems, we have to know how to do it through the limit laws. I would provide the limit laws on the exam. That's a rough set to memorize out of nowhere. Well, I think this is a good stopping point for us then, folks. When we come back on Wednesday's class, we'll talk a little bit about WebAssign, take class questions, and pretty much just continue right here, B and C and so on, finishing off the notes. Any questions at all then, folks, before we call it a night? Okay, well, have a great evening, everyone.
Really quick.
Sure.
I just had kind of looping back what you said at the very beginning of class, like if someone couldn't make it into class, they can always do Zoom. Could that be vice versa? Like if I wanted to come into class, I could do that.
Oh yeah, sure. I would never turn someone away from the class from joining in. You're absolutely welcome to drop in. Even if you want to just take the exam in class, you're welcome to do that as well.
Okay, cool. Thank you.
Yep, you betcha. Oh, and as far as the class recordings go, what typically happens is I'll go here, click on stop live stream. And sometimes that works, sometimes it doesn't. It says it's still live for some reason. Then when I wake up the next class or the next day, I upload the video to the playlist. It's going to end up right here under recorded lectures. Usually that should be done before 11 a.m. on the next day. And that's pretty much my habit and process. If you notice something's missing here, never root to email and just double check if I forgot something. Probably that's what happened is I forgot something. Any other questions so far, folks? Okay, if you do still have questions, feel free to hang around in the class or in the Zoom meeting. I'll be very happy to help out. And usually at the end of the day, I just kind of hang out around here, probably no later than 8:45 or something like that. If there's no more questions, then I pretty much just take off myself as well. Have a great night, folks. Drive safe, and I'll see you all on Wednesday. You bet. Sorry, say again?
No class Monday.
Next Monday? Yeah, that's right. That's going to be Martin Luther King Jr. holiday. Yeah. Yep, you bet. Thank you too. Yep, you bet. Have a good one. And drive safe out there. They said the conditions are going to turn into like a winter blizzard situation soon. Yeah.
Have an excellent day. The lecture was quite interesting.
Awesome. Glad to hear that. You have a good one as well.